sequence, I decided to again go with all the factoring stuff right off the bat and then switch back to the graphing portion of it. So here, some of these notes are maybe a little outdated because you've seen this before, so I didn't get a chance to change all the stuff here. Basically what we're doing is rational functions, as you can see, are just polynomial divided by polynomial. Okay? And what we're going to do here is graph them, where the generic rule for these things is that they'll write it as f of x is p of x divided by q of x. Or basically it just means p and q, or p of x and q of x are just polynomials, just like we just did. Okay? The last problem we did at number 15, it was solve the equation that dealt with polynomials, and each one of those polynomials was a fraction. And that's how those things look. Today we're going to look at what those graphs do. Now the easiest one to start to look at that you guys have all done is 1 over x. 1 over x is a rational function. Okay? Now go back to the idea of when you guys first learned graphing, what did you always do? What's that? Value. You pick numbers, right? You make a table. So, first of all, what can't x be? 0. Why? Okay. So what I would do right away is x can't equal 0. All right. Then what we would do is we would pick values. You've done this before. X generates a y. You'd pick -2, -1. We can't use 0, but we'll use then 1 and 2. And it works out to be rather quick. You put -2 in there, you get 1, -1/2, -1, 1, and 1/2. Now, we've done this next piece as well. When I do, this one is a separate piece. What if I pick -1/2 for x? That's 1 divided by -1/2. What do you get? Very good. You get -2. Then what would 1 divided by 1/2 be? 2. Okay. So graphically, what this guy's starting to look like. You guys ever heard of a vertical asymptote? Okay. Vertical asymptote is where x equals 0, where you get where your denominator equals 0. Okay. Your vertical asymptote, no matter what, will always be at whatever makes the denominator equal to 0. Here, our vertical asymptote is at 0. So in order to show what that you have a vertical asymptote, it winds up being a dotted line at those values. I'm just going to put that little dotted line because it's at the the vertical axis. So I didn't want to mess around with it too much. Okay, since it's at x equals 0, it's the y-axis there. So we label it. There's my asymptote at x equals 0. Okay. And now, just like you've done before, we plot points. Well, we have -2, +2. At -2, it was a -1/2. So here. At -1, it was -1. And at -1/2, it would drop to -2, didn't it? So we'll say that's a half, sorry. Okay? And then on the other side, it mirrors it. 1, 2/2, 1/2, 2. So what's happening is, as you're getting, if I pick -4, would it be -1/4? If I pick 4, it would be 1/4. If I pick 1/4 for x, my value for y would be 4, and so on and so on. So what you're creating here is called a hyperbola. It gets infinitely closer. It's going to get infinitely closer and closer to both the x-axis and the y-axis. Correct, because you can always get closer to it. Okay. So what happens here in this case, we also have asymptotes at the x-axis as well. There would be ways for us to figure out where the x and y asymptotes will be, and we'll get to that here in a second. But in essence, this is what we're going to be graphing. We're graphing stuff that wind up with asymptotes. We're going to graph stuff that aren't just a curve like we're used to with parabolas or dances and things. Now we're dealing with a hyperbola, if you Okay. All right. So to the rules. First of all, remember what these meant, domain and range, before I get too far? Good. Now you're right, x and y, but domain is possible x values, range is possible y values. Okay. So your domain is the set of possible x values, and the range is the set of possible y values. You know what the easy way to remember that is? That was good. Well timed.
That's my dad.
Well, tell your dad we said hi.
Okay.
Yeah, it's the dumb way to remember it, but yeah. If you just remember what comes first in the alphabet, domain comes before range, and x comes before y. Okay. In this last problem, a second ago, we had, it was an asymptote at x equals 0, and there was an asymptote at y equals 0, because you can get infinitely closer and closer, you're never going to get there. So the way that I would write it, it's my domain is the set of x values such that x does not equal 0. Okay? The range is the set of y values such that y does not equal 0. There's a couple other brackets that get thrown into that. Bless you. Bless you. Oh, thought you had a second one.
I did too.
Please go for it. Just don't use your sleeve. You can use his sleeve. It is kind of gross. Raylan's sleeve though. And so, okay. Technically there should be brackets here, but whatever. As math goes on, I'm sure you remember this last year from abbreviations and things like that. We make up symbols for everything, just because why write it out? That's the way we look at it. Okay. So here's what things happen. Let me skip over to this. We get this thing called a rational function that's in this generic form of y equals a over x minus h plus. Okay. Hey, look at that. A, h, and k. Where have we seen that before? I don't know, right? Just, it's been everywhere. A, h, and k's are always going to be around. So what happens is, we're always going to have, let me write this off the side so we can reference it. So we get this y equals a x minus h plus k, where your vertical asymptote is always going to be the 0 of the denominator. Okay. So that's going to be at x equals h. Your horizontal asymptote is always going to be at y equals k. So go back to the one we just did a second ago. It was 1 over x. What was the h value? 0. What was the k value? 0, because it wasn't there. That's where that came from. All right. So what happens is you're going to basically plot your asymptotes first, and then pick a couple of points on either side of the vertical to get the general idea of the curve. It's really easy. Okay, when it's in this type of format. All right. So I like to use the generic equation. We're just going to use -2 over x plus 3, all subtract 1. And I go through the process of what you would do to make all of that work. I'm going to clean here. And I'm not going to use graph paper. This graph paper is for losers. Look it over there. But it's okay. It's okay. I just don't. I normally don't use graph. I like you guys to sketch it yourself. I like to have the rough sketches. I'm a. No, I know, and that's it's. I jokingly say it's for losers. There's a time and place for graph paper. I like to make sure we have equivalency. So that's kind of what I look at. All right. So this case here. In this case here, we wind up with our. I always label what my A, H, and K is, just to go through the process. All right. So our A value is -2. Our H, what's my H value? -3. Good. Remember, it's always the 0 of the denominator, so it's -3. And our K value is at -1. So far, so good? So here's what you do. Generic XY grid. We have a vertical asymptote at -3. That's a dotted line there. And then you have a horizontal asymptote at -1. So basically, if you think about it, I've just shifted my x and y axis, 0, 0, to be over at -3, -1. And that's my new boundary spot, both sides. Okay. So what we do is we just pick some points. Oops. I'm going to pick a couple of points to the left of it, a couple of points to the right of it. So I'm going to use -4 or -5, -4, -2, and -1. All right, and walk through what my values will be. So what's -5 plus 3? -2. What's -2 divided by -2? What's 1 minus 1? See how easy that was? So at -5, I'm at 0. I do it again, -4. What's -4 plus 3? What's -2 divided by -1? 2. What's 2 minus 1? 1. What does this tell you that that side is doing? What direction is that side going? Yep. That side's kind of skating this way, isn't it? All right. So on the other side, it should be doing the opposite, if you math it correctly. So we try it again. What's -2 plus 3? 1. -2 divided by 1 is, and then subtract 1, you get -3. So 2. Take a guess. Where should the next point be? Above that one or below it? Should be above. Good. Very good. Very good. So we check it. What's -1 plus 3? +2. -2 divided by +2? -1 minus 1? There's our curves. Now here's what we do. We hug the asymptote, go through the points, hug the asymptote. Hug the asymptote, go through the points, hug the asymptote. That's all we gotta do. We plot a couple of points on either side, and we label our asymptotes. It's not difficult, really. What's that? It's not difficult, it's just a matter of going through the process to do it. And with this style equation, that's all you have to do. Yes, yes. And there's actually, the axis of symmetry of this is not your vertical. Your axis of symmetry is diagonal. And we'll talk.
Yeah, that's a butterfly.
But we'll actually. Wow. See, you missed out yesterday. That's why she wants to make fun of you today. Or were you here later in the afternoon? All day? Maybe I'll do that one more. Alright, let's try another one. Let's try one more like that. Only I can bully. Who am I bullying? Braylon? You can bully me. Let's try one more. Remember, as you go through these things, guys, the idea is to always, always, always label your A, H, and K first. Plot your asymptotes. Pick points. Pick 2 points on on both sides of your vertical asymptote, and that will give you your points. Okay? It's very procedural for this stuff. Tomorrow is when we get into a little bit more thinking. So let's see. A, what's my A value? Negative 1. What's h? Is it negative 4 or positive 4? It's positive 4. And my k value? Positive 3. That means my vertical and horizontal asymptotes, my vertical asymptote is at the 0 of the denominator because it can't be positive 4. My horizontal asymptote is at 3. Okay? Which means what values of x should we be choosing? I should be picking 2 and 1. I'm sorry, 3 and 2, excuse me. I looked at it wrong. 3 and 2, and then the other side would be 5 and 6. 2 points on both sides. So what's 3 minus 4? Negative 1. What's negative 1 divided by negative 1? 1. What's 1 plus 3? 4. Nice one, math works well. So at 3, I'm at 4. Okay? What's 2 minus 4? Negative 2. Negative 1 divided by negative 2, 1 half. 1 half plus 3 is 3.5, right? So for argument's sake, can I just put 3.5? I mean, not a huge fan of decimals, but it's easy just to plot that real quick. It's 3.5. So we're at 2, and we were at 3.5. So did it move up or down? It moved down. That's enough to give me the idea of what way this is going. Okay? So the other side should be, if we do this right, it should be occurring in this region here, shouldn't it? Yeah, so that's why we check it. So at 5, what's 5 minus 4? 1. Negative 1 divided by 1? Negative 1 plus 3? 2. So at 5, we're at 2. So should the next one be above it or below it, you think? It should be above it, yeah. Very good. That's the thing. You should start to catch which, if it's bouncing one way, it's got to bounce the opposite direction because of the symmetry. 6 minus 4. 2. Negative 1 half divided by 2. Wait, I'm sorry. Did I say? I said negative 1 half divided by 2. Sorry. So 6 minus 4 is 2. Negative 1 divided by 2 is negative 1 half. Add that to 3, you get 2.5. And your idea was correct. It was moving up. So hug your asymptote, go through your point. Oops, whoa. Hug the asymptote, go through your points, make the turn. Hug the asymptote, go through your points. What do you mean? Flip in way like this, so it goes towards each other? Not with the rational function. Okay, not with the rational function. That's something different. We'll look at those after Thanksgiving. Those will be what we call ellipses. Skill check.
Wait, somewhere we put tomorrow, it uses the same stuff, but we take it more stuff. Wait, this is? Oh. You homework for the last couple of days? You got 15 minutes, and you should be able to finish this out. No calculator.
All right.
I'll write down some problems I want you guys to look at from this. Well, good, guys.
the textbook, it says from number 12 to 13, just to identify asymptotes. I just want you guys to see that. So I put 4 graphs on there of the style we just did today. We'll do the other styles of graphs tomorrow.